Good morning all. Time to fix the vacuum cleaner. This is the vacuum cleaner. It is Silvercrest brand, so that was bought from Lidl, and it has this battery which is 6 cells, and it doesn't work anymore. The thing won't even switch on. If you plug in the charger, all 4 lights come on, but if you press the switch, which is on the top here, it don't do nothing. 22.2 volts, so that's 6 cells, 2400 milliamp hours, that's the capacity of each cell, and also the whole pack. Milliamp hours kind of works for everything. Let's get these screws out. 2 of them are Torx, 4 of them are Phillips, and have a look inside. Now I suspect that there's a dead cell in here. This vacuum cleaner gets a lot of use, and it's worked for about a year, but now it's packed up. Don't get any use from me, I have to admit, but yeah, it is thrashed. So I suspect that one of these cells has just died, but it might help if I add this in, which I bought specifically for this, which is a 6-cell active balancer. The only trouble is it's not going to fit in there because it's too wide. But I think if I cut these edges off, approximately along the lines of cutting these holes off, that will fit in there. And then I can wire it in with its 7-way cable to the 7 connection points on the 6-cell battery and balance this thing up. And this will always work. It just works permanently. So whenever this thing is either empty or full or halfway charged, it will get balanced by this balancer. So the issue here is that I have to cut off these 2 sides. Now, why is this thing so wide in any case? Well, I suspect that what's happening is that these large copper planes are being used as heat sinks, because these circuits do get quite warm when they're shoveling their, well, I think they say 1.2 amps. Well, whatever it is, this thing does get quite warm. I don't think it's going to be an issue from the point of overheating if I cut off a sort of 3 or 4 millimeter sliver on both sides of this board. What I'm more concerned about actually is where do the tracks for these 5 LEDs, which clearly need to connect into the 5 circuits, where do they go? Do they go around the outside? I hope not. Now, I can't see any tracks connecting to these LEDs, and in fact all there are 5 little wires there and 5 more wires. So I don't really know where they're connected. However, on this one, which is a 3-cell, it has 2 active balancer circuits, it's for 3 cells, it has 4 connection wires. On this one, you can see where the traces go from these LEDs, and they run up to the little now what is it? Little resistor, I can't remember the number. Yes, that resistor just next to the 3, which is a 202. So that's 2000, so that's 2K. And that sounds about right for an LED, a modern high brightness LED. And I think you can just about see that the trace runs from that 202 down to the LED marked 2-3. And from the other 202, which is up on the other circuit, round the side under that lettering and to the LED marked 1-2. So that's the circuit. It's the 202 resistor, and this one does have these resistors marked 202, but I suspect this might be a 4-layer board because there's absolutely no, actually I should be down this end really, shouldn't I? There's no evidence of any connections running from the 202 resistor, which you can see on the right hand side there, and the LEDs, so I suspect it's in the middle. Now my only concern is whether or not those connections run outside here. It'd be okay if they ran underneath these diodes, that would be fine, but I don't want them to be in this area, which I'm about to cut off. Right, we're going to need a nice new blade for this because this is long since blunt. So how does this work? There's a button that you press there. Oh, that moves the whole sort of tray containing the new blades out. Oh yeah, slide that off. Yep, that's the blade snappy thing. Let's get snapping. snapping away. Yeah, right, that should be sharp enough, I hope, to carve the sides off this. Right, I'll use this PCB as a sort of ruler. I'm going to go right up to the pads that these diodes are connected via, on I should say, not via, that's a confusing term, and make my first sort of cut. It's not holding together. I should clamp all this together, but I haven't. And now just lots of carving through this lovely thick copper, and don't worry, I'm not going to subject you to watching this because it's going to take hours. Right, I've scored down, I don't know, 0.5 millimeter or something. Let's have an initial go at breaking this off. I think I need my big pliers. I think they're in the shed. Big pliers to try and break this. Seems to be breaking. I have scored it both front and back, so it should come off reasonably cleanly. I haven't run the scores beyond the holes because it just was very difficult to do that, so that won't be as clean, but I don't think it'll be a problem. Okay, let's go back the other way and hope that there's no trackery outside of my score lines. Okay, bit of filing now on this bastard file. Better do that over the carpet. Well, we're going to need the vacuum cleaner to work after this because there's quite a lot of mess on the floor. So that's smoothed the edges down. Now the question is, will that fit in there? Oh yes, just about. It's quite a tight fit, but yeah, it does fit. Now will it fit, if I get that back out, will it fit with its cable connected? Where's the cable gone? Yeah, I think this is going to work. So if I plug that in to the socket while it's in the final position, I can get it in, which is not proving to be very easy. Right, that's good. And then I think what I'll do is I'll thread each of these wires in turn back through here, and then they will come out onto the top of this board, and I'll cut them and solder them onto the relevant positions. Right, black will be most negative, so we've got B0 there, B1, 2, 3, 4, 5, 6. B6 is clearly positive, B0 is the can of this cell, so that's the most negative. So black will cut and solder onto there. Right, let's strip this wire. Only need couple of millimeters exposed. I didn't turn the iron on. Turn the iron on and solder that onto B0. Now I don't think any of these lights, they're slightly hidden under there now, but I don't think they'll come on until I've got 3 wires on, because then that means that yes, 3 wires. You might actually need, no, 4 wires would mean that you've got 2 active transfer units, so 3 wires will have 1 active transfer unit. Yeah, so let's get 3 wires on. So the first wire is my B0 most negative point. Oh, we've got a lot of copper there, so I'm going to take the temperature of this up to 400 because it just isn't melting the solder very well. Okay, that's up to temperature. That's better. Right, that's my most negative. Something smells, but then I am soldering, so that's probably normal. Yeah, I'm just worried about burning smells because, I mean, this is all powered up. There's nothing I can do about that. And I keep smelling burning smells. Right, B1 will be this orange one. I'll just check that. And then next is white. So let's tin the orange with my 400 degree soldering iron. Yes, you get much more violent smoke at 400 degrees. Okay, let's put that on there. And, ooh, don't want my solder lying on the PCB. So no light yet, but then that's entirely expected. Let's get white. I'm not sure whether these shorting together is a wonderful idea, but I'll just have to see how it goes. For the moment, thread white in, and that will go to B2, which is over here. In fact, I'm actually going to cut these slightly short just to get rid of the exposed ends, because I don't want to blow this up unnecessarily. So that should prevent any accidents. Right, let's get this white one stripped. You need a couple of millimeters on there, tinned and connected. Tinned and connected, so B0, B1, B2. Any lights? Can't see any. But I don't think, I think the dead cell or the low cell is this one, 2 to 3. So we may see something when I connect the next wire, which appears to be blue. Right, let's connect blue to B3 and see if lights come on. Lights have not come on. Of course, the other reason that lights may not have come on is because I might have cut all the connections to the LEDs off. What fun! I'm just going to inspect that copper edge to see whether I can see any copper on middle layers. I couldn't through the camera. Let's see if I can do it in reality. Right, I've just soldered yellow to B5 and we have a light on. So certainly the active balancer is working. I can't remember which cell was the dud cell. I've only got one more wire to solder, so red to B6. So let's get that on and start doing some... Oh, that light's gone off already. Let's come back on again. And start doing some cell measurements. What bothers me a little bit is that these lights seem to be coming on and going off really quickly. Why would they come on for such short bursts like that and then go off again? That's really strange, but I'll go with it for the moment. That's light 3-4. I think I've seen the left-hand 3 lights here, but not the ones further down. But yeah, I'll just go with it. I'll put this back in its box. Nothing seems to be getting warm, apart from these transfer units. The inductors are mildly warm, not hot. But yeah, that's not behavior that I've seen before on these active balancers. Let's see if the vacuum cleaner works. It would be nice to see these LEDs through the plastic, but then this battery is going to be in the vacuum cleaner, I suppose, most of the time, so we'll just have to not see them. But certainly there's enough space for the wires. Right, that's good. Let's get some screws in. And no, it doesn't work. Let's take the battery out, put it back in. No, it doesn't work. So I'm still seeing these lights coming on periodically, but let's get some voltage measurements, make sure I'm not in the 10 amps socket. No, I'm not. Okay, 3.1, so that's low. Where do I go now? B1 to B2. 3.1. 2.7, negative is irrelevant really. 2.7, that's alarmingly low. 2.6, so this thing's empty. And yet, when you put it on the charger, 2.5, which way am I going? 4, 5, 6. Oh, what's that? 300 millivolts? What has happened there? 300 millivolts. That's a concern. And that's not going up. So do I have a problem where the balance charger is not actually seeing that and pushing it up? That's a worry, isn't it? 4 and 5 was 2.5 volts. Yes, this pack's a bit dead. So I put my charger onto the cell that's at 300 millivolts. Of course, now it's not at 300 millivolts. It's at, oh, why can't I measure it? 3.63 volts. Oh, that's moved. Why won't that stay in there? But I'm not hopeful. That's in constant current, so it is making a connection periodically. I'll just have to charge all these cells because they all seem to be low. But yeah, as I say, not hopeful, but I think I'll end it here. Well, update. I'm now charging with about 500 milliamps cell 1, which is over here, and I am seeing some movement on cell 6 because that was down at 3 volts earlier, so that's now 3.1, and it is creeping up. And every now and again, when the transfer units switch in and out, you see a large change in this, a sudden movement. So the transfer units do seem to be working, and I think they're all working, even though 2 of the lights aren't working. So I think perhaps I've severed the wires to the LEDs, to 2 of the LEDs. Now it is possible I could repair them because I know where the resistor driving them is, and I know where the LED is, so I could strap a little thin piece of wire across. I don't really need to, if I can see that there is energy being transferred between all the cells, and it's certainly coming into cell 1 and seems to be accumulating in cell 6, then I'm happy that this process is working, and I will just leave it. Oh no, there's a sudden change, but that actually might be dodgy connections here. I don't know, because I'm using magnets to get my connections. But yeah, sometimes you see this sudden movement. But I'm just going to leave it now with half an amp, which you can see there, 0.497 going into cell 1. This is set for a maximum of 4 volts, so it'll take the whole thing without any intervention. It'll take cell 1 up to 4 volts, and that'll trickle across to all the cells. Yeah, just leave it for several hours and see what happens. The vacuum cleaner works. 4 LEDs. And yeah, the battery's fine and everything's fine. Oh, I could have cleaned that, couldn't I? So, what did this need ultimately? Because it wasn't as simple as just putting in that active balancer, which I think I broke. I think I cut 2 of the lines, or the tracks, to 2 of the LED indicators. Let's see what I had to do. I'm sure this active balancer will help. Perhaps I'll fix the broken tracks, because I know that the light emitting diodes, the LEDs, go to the 202 resistors, so I could just solder short wires on. But yes, it appears I did cut the traces. Let's just have another look at the edge of that board. Yes, I think you can see the inner layers. There's a line of copper just below the top line of copper, and on the bottom it's harder to see, but I think there's also a line of copper. The inner layers are very close to the outer layers. They're not equally spaced throughout the thickness of the board, but yeah, pretty sure I cut traces that go between these transfer circuits. I think all the transfer circuits are working fine, but the traces that go to those 5 LEDs down there. Anyway, what I did ultimately was I changed a cell. I had this pink Samsung cell knocking about. It's a similar capacity. This is a 26. These I think were 2400. Actually, they're marked 25. So 25, yeah, 25 HP. So they're going to be very similar. I soldered this because I don't have a welder. If you use a very hot iron, and my Ryobi iron is hot enough for that, you can solder them. So yes, that's not very pretty, but it's all attached. You can solder them with a very hot iron. That could go back on there, couldn't it? Yeah, well, I might as well shove it in the box. So yeah, the fix was ultimately a replacement cell. That one was dead. Anyway, the wife's happy. She can go back to her, well, almost daily vacuuming. She's a vacuumaholic. She just vacuums so much. That's why this thing had a fairly short life. It only lasted about a year. Anyway, new cell fixed. Cheerio.